Oh, here is the algorithm of QuickSort. So, the main idea of QuickSort is at each round, we choose a pivot element from the array and we move all the smaller items on its right and all the larger items on its left. And we recursively do this till the array is sorted. Okay, so let's explain that step by step. So first step, we choose a pivot. We choose a pivot. The pivot can be any element in the array. So we make the first element to be the pivot. So that means the 4, okay? So the second step is to move things, move elements. So at this step, there are 2 sub-steps. From left to right, okay, from right to left, from right to left, we find the smaller ones. And from the left to right, we find the larger ones. That means first we checking this array from this direction. From this direction, we find a smaller. We try to find a smaller and move it to the left side. And then we check from left to right. Okay, we looking for the larger items and move it to the right. Okay, here is this QuickSort does. So this is the end, and this is the start. Okay, so first we do this right to left, looking for smaller. Right to left, right to left, okay, right to left, look for smaller. So in the end, it's 2, right? 2 is smaller, right? So we find the smaller items. We move this 2 to the start location. We move this 2 to start location. Then we need to move this start location to right by 1 step. Okay, this is the first sub-step. And then we do this, left to right, left to right. We try to find a larger. Okay, so from the start to right, we try to find larger. So okay, at location start, it's 5, right? 5 is larger than 4. Okay, we found it. What do? We move this 5 to end location. Okay, we move 5 here, and we need to move this end to the left by 1 step. So now we just finish this left to right, find larger. And then we recursively do these two steps. Okay, right to left, find smaller. Okay, so now the right element is 6, which is greater than 4, not smaller, right? Okay, we move this end left 1 step. Okay. Oh, by the way, until we find this smaller, we switch to the other step, right? If we don't find it, we keep looking. That means if we didn't find a smaller element, that means that element is on its right position for now. Okay, here at end it's 3. 3 is smaller. Okay, we found it. What do we do? We move this 3. We move this 3 to the start position, and we move the start right by 1 step. Okay. After that, we again need to do this, okay? From left to right, find larger. Okay, left is 9. 9 is larger. Okay, again we found it. It's 9. What do? We move this 9 to the end position, and we move this and left 1 step. And then again we need to do this step, right to left, looking for small items. Okay, 1 is smaller. Okay, we found it. What we do, we move this and we move this 1 element to the start position. Okay, and then we move this start right a step. Okay, so now you can see start and end are at the same location, which means we need to stop. And this position, this start and end position, is where this pivot belongs to. So we move 4 here, 4 here. So now this is the 1 round. This is just a 1 round. Okay, 1 round. In this round, what do? We find the right location of the pivot item 4. That means on the left side of pivot are all smaller than pivot, and on the right are all larger than pivot. So what do we do next? So we missed the third step. Okay, the third step, we recursively do the same thing. We name this to left, and we name this part right. We just do QuickSort LEFT and right. And 2, there is only one element left. 2, only one element left. Okay. So what is the time complexity of this algorithm? Let's check it. Okay. So what we just do is one round is one round. And the time complexity for this round should be n. We check all the value except the pivot. So it should be n of one round. So how many rounds we need to do, right? So if for every round what we choose for pivot is just in the middle. It's just in the middle. It's just in the middle. That means we only need log n rounds. But we cannot be that happy, right? We can't that lucky for every round. Might be that. So the worst case is n plus n minus 1 plus n minus 2, which is approximately n square of n square. So, but we cannot be that unlucky, right? So the best case should be n log n. And on average, it should, I think it should be something n log n. And n to the power of 2. Okay. So, okay. So I introduce the algorithm of Quicksort, and I calculated the time complexity of this algorithm. So, okay, that's done.